Okay, so we have a first question here. Congratulations, you have just won a small lottery. It will pay you either five annual payments of 15,000 each, with the first payment to be received 2 years from today, or a single lump sum to be received today. If you can invest at a 6% annual rate of interest, what is the least you should accept as the lump sum pay amount? Okay, so here, colleagues, we are dealing with an annuity. What is the definition of an annuity? Because remember, managerial finance, it's not only calculations, it's also definitions and theory. So, what's the definition of an annuity, colleagues? Yes, Madam Anne? Yeah, yes, a series of equal payments over the same time interval. Okay, so here you'll be receiving 15,000, 15,000 for 5 years, 15,000, 15,000, 15,000. Now, we want to combine that as a lump sum and find its present value. Okay, because here when they ask what is the least you should accept as the lump sum, they're asking you to find the present value of this money which you'll be receiving in the future. You want to find how much you can receive today as a lump sum. Okay. Now, one important point here, they've told you the first payment to be received 2 years from today, meaning in year one, you're not going to be paid. So, what type of annuity do we call this one? Madam Basilia, what do we call this annuity? Madam Chala. Oh, yes, Madam Basilia, you can go ahead. Mm-mm. But thank you for your try, Madam. Deferred annuity. A deferred annuity is where you get your payments at a later date from the starting point. You get your payments. To defer is to delay, so it's like a delayed payment. Okay. So for this question here, when we talk about today, it is year zero. Let me draw this here. Year zero is today. We have year one, year two, year three, year four, year five, and year six. So you initially was supposed to be paid in year one, okay, but you'll be paid in year two. So it means there will be a delayment of 1 year. Okay, your payment for year one is coming in year two. This is when you receive your first payment. Then your second payment year three, third payment year four, fourth payment year five, fifth payment year six. Okay, so there's been a delay of 1 year. Okay, so this is the formula for a deferred annuity here. Okay, CF is just the cash flow. All right, 1 minus 1 over 1 plus R. It's just the same as the formula of the present value of an ordinary annuity. The only difference is we're adding this 1 over 1 plus R to the power D. D just represents the how long the delayment is. Okay. So in this case, the delayment is just for 1 year because you're not getting paid in year one. Okay, so there's a delay of 1 year. So your D equals 1. Colleagues, are we okay with this? Any questions? Remember me, I'm patient. I'm not like a lecturer who cruise where you do not understand anything. So are there any questions, colleagues, before we start the tabulations? Okay. So CF, which is our cash flow, 15,000. R, which is our rate, 6%. So the rate, convert it to a decimal, okay? R, since it's 6%, so we convert it into decimal, 0.06. N, number of years, 5. Okay. D, delayment of 1 year. So it's just a matter of substitution. Where there's CF, you put 15,000. Where there's R, 0.06. Even here, 0.06. As you can see, where there's R, I've put 0.06. Where there's N, I've put 5. And where there's this D, I've put 1. Any questions before we move further? Because remember, we're moving at a pace that everyone should understand. Okay, once you go out of this class, you should remember how to calculate present value of a deferred annuity. So this is the point where now I need you to get your calculators. Okay, so you do this in steps. Okay, because if you try to put all this whole tabulation in the calculator, you might get a wrong answer. Okay, so let's start with here. 1 plus 0.06, we get 1.06. Have you seen where I've circled this red? I've added. Okay, even here, this 1 plus 0.06, you've got here 1.06 to the power 1. Okay, then we move further. So this 1.06 to the power 5, you get 1.336. Okay, 1.06 to the power 5, 1.336. Get your calculators to make sure that it's 1.336, so that when someone is studying alone and they get a different value, they shouldn't panic. Okay, 1.336. Confirm if you've got, is it? Yeah, 1.33. This looks like 8. Have we all got 1.338? Have we all got 1.338? Then, yes, madam. No, don't put it there, madam. This 5 is married to this 1.06 here at the denominator. Yes, don't put it outside. Oh, and colleagues, did we all get let me see, the formula for present value, for the time value of money, or the formula? Wait, with that. This document has got all these formulae. Okay, you need this document. I would advise you print it out if you can. Okay, so this is the formula. Where is this present value, ordinary annuity? Oh yeah, here it is. This is the formula we're using here, and these are from the lecturer's notes. Okay, so when it's deferred, you just add 1 over 1 plus r to the power d. So it will be very paramount, colleagues, that you print this document and you get all the formulae so that you'll be okay. So 1 divided by 1.338, you get 0.747. Okay. Then here, this 1 divided by 1.06. This 1.06 is to the power 1. So it's just the same as 1.06. So 1 divided by 1.06, you get 0.943. Okay. Then we come here, 1 minus 0.747, you get 0.253. 0.253 divided by 0.06, you get 4.216. You get 4.216. Now you multiply 15,000 times 4.216 times 0.943. You're going to get 59,635.2 as your answer. Due to rounding off, you might get different figures, but so long as it's in the range of 59,000, you might get a 58, depending on how you round it off. But if you're in that range, 59, 58, then you are okay. Any questions? Divided by 0.06. Sure. Let's see. 1 divided by 1.338, you get 0.74738. Okay. Then 1 minus 0.747, you get 0.253. Okay. Then 0.253 divided by 0.06, you get 4.216. 66666 like that. So maybe, madam, just check. Okay. Is anyone else getting other figures? Yes. Any questions before we move to the next part? So just remember, for a deferred annuity, okay, it's the same as the present value for an ordinary annuity, but add a 1 plus r to the power d. Now, colleagues, the lecturer might switch up the question. If it's annuity due, this question was they told us these payments are at the beginning of the year and it's annuity due. You are going to use this formula here. Present value of where is that one? There's no present value for annuity due. Okay, the formula for a present value of an annuity due. Remember, you always add a 1 plus r if the payments are at the beginning of the year. Now that annuity due is deferred, okay, you will now include this. Okay. If this question, the payments were at the beginning of the year and it's an annuity due, a deferred annuity due, this would be the formula that you would use. So please find out from your lecturer, does he give the formulae during the exams or do you have to remember these formulae? Yeah. Okay. So we need to do a lot of practice. And as I said, colleagues, we'll be doing catch-up lessons on Saturdays. Okay. So if you're still left behind here, you're still confused here, at least by Saturday, you would have caught up. All right. We can move to the next question. Huh? Madam, those are topics for in the inbox. Is that okay? Is that okay, madam? We move that one to the inbox, okay, colleagues? Um, okay, so we've got this question here. You want to have exactly 8,000 in your account at the end of 5 years. The account allows you to make one deposit at the beginning of each year. Okay, so this, when you see this at the beginning, colleagues, what is it signaling? Mm, okay. The account allows you to make one deposit at the beginning of each year at an interest rate of 9%. In order to have exactly 8,000 at the end of year 5, how much must you deposit each year? So after you read the question, you find out, okay, here I'm dealing with annuity due because I'll be putting the same amount at the beginning of each year. So you know that you're dealing with an thing, um, annuities. Okay, the question is, how much must you deposit each year? Okay, so now here we have to now know which formula are we going to use. Are we going to use the present value formula or are we going to use the future value formula? Because here a lot of confusion can come out. You find you use the present value formula. Mm, o- correct. Okay, because in this question they've already given you the future value here. It's already been given to you. All right. So basically, you want to find out the present value or the cash flow. Okay. You want to find out how much you need to be depositing each year. Okay. So we put the formula for the future value of an annuity due. Okay, this is the formula here. We already have our future value. We have the rate, the number of years. The only thing we don't have is the cash flows. Okay, or how much you need to be putting each day, basically, which is also your present value. So it's all a matter of substitution. Okay, we substitute your values: future value 8,000, cash flow X, the rate 9%, 0.09, number of years 5 years. Okay, So when you're solving this, colleagues, you start here. 1 plus 0.9, 1.09. Okay. Then here, oh, did I put to the power minus 1 here? I never put minus 1. Okay, so we'll put it like this. Okay, so we have 8,000 equals x, open brackets, 1.09. I've added this 1 plus 0.09 to the power 5 minus 1 over 0.09 multiplied by 1.09. Those with calculators, 1.09 to the power 5, what value do we get? Okay, 1.538 minus 1, 0.538, right? Divided by 0.09. All right, so 0.538 divided by 0.09, we get 5.977. 5.977, 977 multiplied by 1.09. So 5.977 times 1.09, you get 6.514. Or 6.515 actually. Then to get the value of x, 6.515, eight thousand divided by 6.515, you get 1,227.93. All right, that's how much you need to deposit for each year. Any questions? All right, no questions. We move to the next one. If the annual interest rate is 10%, how long would you have to wait for before a 17,500 investment at least doubles in value? Give the minimum number of years required. Yes. So, colleagues, which formula are we going to use? Yes, the future value formula. So here it is. Future value. Okay. It was present value 1 plus r to the power n. So basically, we're trying to find the value of n. Okay. They've told us how long we should wait until it doubles. So 17,500 times 2, 35,000. Yes. So that's our future value. Our present value, 17,500. Our rate, it was 10%. Uh-huh. 10%, yes. So here, first thing you need to do, you need to isolate this. When you add 1 plus 0.1, you get 1.1 to the power n. So you want this 1.1 to the power n to be alone. Okay? You want it to be alone. So in order for it to be alone, you need to divide both sides by 17,500. Okay? When you divide this side, 17,500 divided by 17,500, it disappears. 35 divided by 17,500, 2. Okay, so we've got 2 equals 1.1 n. So colleagues, whenever you're trying to find the value of an unknown exponent, you bring in the logarithms. Okay, the logarithms will bring this n down here. Okay, the logarithm brings the n down. So have you seen n log 1.1? And also what you do on the left hand side, you do on the right hand side. Here we have log 2. Any questions? So remember the key, colleagues, okay? When you're trying to find the value of a power, when you bring that power down to the other numbers, include the logarithm. Yes, Madam North, you will have a question? Ah, yes, Madam, where are you lost? Okay. Since we want to find the value of n, so we need to bring it down. So in order to bring it down, that's why we bring in the logs. Okay. In order to bring the power down, have you seen the n has moved down now? Now, when n moves down, that's when the logarithms come in. Okay. Moment the power moves down, introduced the logarithm. Okay, Madam Ruth? To bring the power down, introduce the logarithm. Yes. And when you have brought the power down, you bring the logarithm on both sides. Have you seen? So the logarithm is attached to 1.1 and it's also attached to 2. Uh-huh. No, this two is already, yeah, this two is already down. Okay, this 2 and 1.1, they're already down. Uh-huh. Not 2 to the power 1, madam. Mm-mm. These two here, you're talking about these two here. No, this two, madam, it hasn't got any power. It's think of it as a normal number. It's just a normal number. Okay. So it's not 2 to the power 0, no. Or 2 to the power anything. It's just 2 as itself there. It hasn't moved up or down. It's just stayed where it is. Even the 1.1, it has just stayed where it is. Yes, the end just moves down. Yes. Yes. It's only the power that comes down. And when the power comes down, that's how the logarithms have been introduced. So we want to find the value of n. Okay, so we divide both sides by log 1.1 because we want the n to remain alone. Okay, want the n to remain alone. So you divide both sides by log 1.1. Okay, these cancel each other and we remain with n equals log 2 over log 1.1. Okay, because we want the n to be by itself. So go on your calculators, you just type in log 2. Log 2 is 0.301. Confirm on your calculators. Log 2 0. Okay. Then log 1.1 0.041. So 0.301 divided by 0.041, you get 7.34, which we can round off to 7 years. Now, if you want, you can put in your calculator log 2 in brackets divided by log 1.1 in brackets. I just calculated them individually for your sake so that everyone is seeing what's happening, that everyone is following. Yes. Any questions? It's okay, madam. Okay, it's maybe because here the how I rounded off on this part, that's why our numbers are a bit different. Mhm. If you just Yes. Any other questions before we move to the next part? Okay. ABC company is considering the purchase of XYZ company at a price of 190,000. If ABC makes the acquisition, its after-tax net cash flows will increase by 30,000 per year and remain at this new level forever. So colleagues, when you hear this forever word, what comes into your mind? Perpetuity, yes. Now I've got a question, colleagues. Perpetuity, it says forever. So now if you pass on, in heaven, will you be receiving that perpetuity? Will you receive that perpetuity in heaven? That is your homework for tonight. So if the appropriate cost of capital is 15%, should ABC buy XYZ? So here we have to find first the present value of this perpetuity, and then we should compare it against the cost of purchasing this company to see if we're going to be in a profit or if we're going to be in a loss. If we're going to be in a profit, well and good. If we're going to be in a loss, then we shouldn't buy. So, first things first, you need to get the present value. Cost of capital, colleagues, just means cost of financing. Okay, colleagues? Cost of capital, cost of financing. Okay, so formula for the present value of a perpetuity, PV equals C, your cash flows, over the rate, okay, which is the cost of capital. So cash flows 30,000 divided by the rate 0.15. Okay, 30,000 divided by 0.15, 200,000. Okay, so the value of this perpetuity today is 200,000. Okay, now I want to find out if it's worth buying this company. So this present value of the money that we're going to receive, compare it against this cost of 110,000, 190. Uh-huh. Okay, where do you want me to start from? Okay, we're dealing with the perpetual. Or when we the forever, it tells you that you're dealing with a perpetuity. Okay. So this company, if XYZ, if ABC buys XYZ, it expects to be receiving 30,000 per year forever. So I want to find the present value of this perpetuity. Okay, and the present value is the cash flow, CF, over the rate. The rate we're going to use is the cost of capital here, 15%. Cost of capital, cost of financing. Okay, then you just divide 30,000 divided by 0.15, you get 200,000. Now, want to see, is it worth purchasing this company? Want to find out if it's worth purchasing what company we're buying here. If it's worth purchasing XYZ. So we're going to compare the present value of this perpetuity minus the cost, 190,000 here. So 200,000 minus 190,000, we have a profit of 10,000. So ABC can buy XYZ because there's going to be a profit for them. If this was a negative value, you would advise do not buy the company because the present value of this money that you'll be receiving forever, it's less than the cost of the company. Okay, that's what it translates to. Okay. Any questions? Okay. Uh, Let me just do one more question. I have to go. I've got another class at 22 hours. So let me just do this question here. Aria is planning to invest in a new machine costing 150,000. The company anticipates that the machine will generate additional cash flows of 50,000 per year for the next 4 years. The discount rate for these cash flows is 10% per year. What is the present value of the expected cash flows from the machine over the next 4 years when it has been discounted semi-annually? Colleagues, what are we dealing with in this question here? Yes, we're dealing. This is net present value technique. Yes, net present value technique. So, since we're going to be receiving the same money, 50,000 per year for the next 4 years, so we can take this as an annuity. If these cash flows were different, would have used the normal technique for the net present value. But since the cash flows are the same, so we can use the present value of an ordinary annuity. Okay, colleagues, if the question doesn't say beginning or end of the year, assume ordinary annuity. That's what I forgot to mention. Okay. If it's silent about beginning or end of the year, just assume ordinary annuity, unless it is stated otherwise. So present value for ordinary annuity, PV equals CF isn't writing CF 1 minus Now here they've told us that it's being discounted semi-annually. So what will our N be? We're discounting semi-annually. What is our N going to be? Four times two is N is, oh, so since here we're already using N, so okay, I'll use M to represent the compounding. Since N in this formula is number of years is 4 years. So for the compounding, we use M, okay, colleagues? So since it's semi-annual, so M is 2, okay? So whenever you are compounding, colleagues, remember you multiply the time by the number of compoundings and you divide the rate by the number of compoundings. Let me zoom in. Okay, colleagues, if there is any compounding in these questions, okay, the rate you divide it by the number of compoundings and the time you multiply it by the number of compoundings. Okay, colleagues, the rate divide by the number of compoundings, the time multiply by the number of compoundings. Just remember that rule. All right, so let's see. So if you want, you can divide them before you put them in the formula, or you can use them in the formula. What I advise most is do the adjustments before you put in the formula. So R, which is our rate divided by M, is going to be, so I'm going to say 10% divided by 2, 5%. Okay, so wherever there's R, we'll put 5%. Then N multiplied by M, so the number of years is 4 years, multiplied by 2, you get 8. Are we all clear with this part, colleagues? Yeah, yeah, yeah. Okay, how did I? The number of compoundings. So since we've been told uh, it's been discounted semi-annually, so M equals 2, since it's semi-annually. No, it means twice per year. Yes, the other question? Uh-huh. Uh-huh. Well, it's part of the formula for present value of ordinary annuity. This you're talking about this one here, right? This one here, yes, it's part of the formula. Sure, it is here. So whenever there's compounding, just remember this divide this divide, and this multiply. They'll tell you, they'll say it's either here, like they've said, it's discounted semi-annually. Maybe they can say it's discounted quarterly. If it was quarterly, what would M be equal to? No, 4, yes. Mm. If it's monthly, what would M be? 12. Uh-huh. Daily, 365. Yes. Weekly, yes. Have we all got that, colleagues? Yes. So we just do our substitutions. CF, cash flow, 50,000. Open brackets, 1 minus 1 over 1 plus. So since we've already divided here, 0.05 to the power 4 times 2, 8 over 0.05. So it's at 1 plus 0.05, that is 1.05. Let's get our calculators. 1.05 to the power 8. 1.5 to the power 1.05 to the power 8. We get 1 divided by, oh wait, first wait, 1.05 to the power 8. That's 1.477. Okay. 1.05 to the power 8, 1.477. Then 1 divided by 1.477, we get 0.677. So I'm doing it step by step so that no one is getting confused. So we have 1 minus 0.677 over 0.05. Okay. So we're going to say 1 minus 0.677, you get 0.323. Okay. Then we're going to say 0.323 divided by zero point zero 0.05, you get 6.46. Okay. Then 50,000 times 6.46, 323,000. Yes. Any questions?